Welcome back. In the last video, we covered some of the PyTorch model building essentials. And look, I linked a cheat sheet here. There's a lot going on. There's a lot of text going on the page. Of course, the reference material for here is in the Learn PyTorch book, PyTorch Model Building Essentials under 0.1, which is the notebook we're working on here. But I couldn't help myself. I wanted to add some color to this. So before we inspect our model, let's just add a little bit of color to our text on the page. We go to, here's our workflow. This is what we're covering in this video, right? Or in this module, 0.1. But to get data ready, here are some of the most important PyTorch modules. torchvision.transforms, we'll see that when we cover computer vision later on. torch.utils.data.dataset, so that's if we want to create a dataset that's a little bit more complicated, then because our dataset is so simple, we haven't used either of these dataset creator or data loader. Then if we go build or pick a model, well, we can use torch.nn. We've seen that one. We've seen torch.nn.module. So in our case, we're building a model. But if we wanted a pre-trained model, well, there's some computer vision models that have already been built for us in torchvision.models. Now, Torch Vision stands for PyTorch's computer vision module. So we haven't covered that either, but this is just a spoiler for what's coming on later on. Then at the optimizer, if we wanted to optimize our model's parameters to better represent a data set, we can go to torch.optim. Then if we wanted to evaluate the model, well, we've got torch metrics for that. We haven't seen that, but we're going to be hands-on with all of these later on. Then if we wanted to improve through experimentation, we've got torch.utils.tensorboard. What's this? But again, if you want more, there's some at the PyTorch cheat sheet. But now this is just adding a little bit of color and a little bit of code to our PyTorch workflow. And with that being said, let's get a little bit deeper into what we've built, which is our first PyTorch model. So checking the contents of our PyTorch model. So now we've created a model. Let's see what's inside. You might already be able to guess this by the fact of what we've created in the constructor here, in the init function. So what do you think we have inside our model? And how do you think we'd look in that? Now, of course, these are questions you might not have the answer to because you're like, Daniel, I'm just starting to learn PyTorch. I don't know these, but I'm asking you just to start thinking about these different things, you know? So we can check out our model parameters or what's inside our model using, wait for it, dot parameters. Oh, don't you love it when things are nice and simple? Well, let's check it out, hey? Well, first things we're going to do is let's create a random seed. Now, why are we creating a random seed? Well, because recall, we're creating these parameters with random values. And if we were to create them without a random seed, we would get different values every time. So for the sake of the educational sense, for the sake of this video, we're going to create a manual seed here, torch.manualSeed. I'm going to use 42, or maybe 43. I could use 43 now. 42, because I love 42. It's the answer to the universe. And we're going to create an instance of the model that we created. So this is a subclass of nn.module. So let's do it. Model 0, because it's going to be the 0th model, the first model that we've ever created in this whole course. How amazing. Linear regression model, which is what our class is called. So we can just call it like that. That's all I'm doing, just calling this class. And so let's just see what happens there. And then if we go model 0, what does it give us? Oh, linear regression model. Okay, it doesn't give us much. But we want to find out what's going on in here. So check out the parameters. So model 0 dot parameters. What do we get from this? Oh, a generator. Well, let's turn this into a list. That'll be better to look at. There we go. Oh, how exciting is that? So parameter containing. Oh, look at the values. Tensor requires grad equals true. Parameter containing. Wonderful. So these are our model parameters. So why are they the values that they are? Well, it's because we've used torch rand n. Let's see what happens if we go, let's just create torch.randn1. What happens? We get a value like that. And now if we run this again, we get the same values. But if we run this again, so keep this in mind, 2, 3, 4, 5, actually wow, that's pretty cool that we got a random value that was all in order, 4 in a row. Can we do it twice in a row? Probably not. Oh, we get it the same one. Now why is that? Oh, we get a different one. Did we just get the same one twice? Oh my gosh, we got the same value twice in a row. You saw that. You saw that. That's incredible. Now the reason why we get this is because this one is different every time because there's no random seed. Watch if we put the random seed here. Torch.manual seed. 42. 3367. What happens? 3367. What happens? 3367. Okay? And what if we commented out the random seed here? Initialized our model. Different values. 235. 2345. It must like that value. Oh my goodness. Let me know if you get that value. Right? So if we keep going, we get different values every single time. Why is this? Why are we getting different values every single time? You might be, Daniel, you sound like a broken record, but I'm trying to really drive home the fact that we initialize our models with random parameters. So this is the essence of what our machine learning models and deep learning models are going to do. Start with random values, weights and bias. We've only got 2 parameters here, but the future models that we build might have thousands. And so, of course, we're not going to do them all by hand. We'll see how we do that later on. But for now, we start with random values, and our ideal model will look at the training data and adjust these random values. But just so that we can get reproducible results, I'll get rid of this cell. I've set the random seed here. So you should be getting similar values to this. If you're not, because there's maybe some sort of PyTorch update in how the random seed's calculated, you might get slightly different values. But for now, we'll use torch.manual seed.42. And I want you to just be aware of, this can be a little bit confusing if you just do the list of parameters. For me, I understand it better if I list the name parameters. So the way we do that is with model 0, and we call stateDict on it. This is going to give us our dictionary of the parameters of our model. So as you can see here, we've got weights and we've got bias, and they are random values. So where did weights and bias come from? Well, of course, they came from here, weights, bias. But of course, as well up here, we've got known parameters. So now our whole goal is what? Our whole goal is to build code or write code that is going to allow our model to look at these blue dots here and adjust this weight and bias value to be weights as close as possible to weight and bias. Now, how do we go from here and here to here and here? Well, we're going to see that in future videos, but the closer we get these values to these two, the better we're going to be able to predict and model our data. Now, this principle, I cannot stress enough, is the fundamental foundation, wow, good description, Daniel. The entire foundation of deep learning. We start with some random values and we use gradient descent and backpropagation plus whatever data that we're working with to move these random values as close as possible to the ideal values. And in most cases, you won't know what the ideal values are. But in our simple case, we already know what the ideal values are. So just keep that in mind going forward. The premise of deep learning is to start with random values and make them more representative, closer to the ideal values. With that being said, let's try and make some predictions with our model as it is. I mean, it's got random values. How do you think the predictions will go? So I think in the next video, we'll make some predictions on this test data and see what they look like. I'll see you there.